All right, hello and welcome back. So we are continuing our studies of LTSpice from the very simple circuits that we built in the previous video. And if you are observant or you paid attention, you would realize that this current that I'm measuring here is showing as negative 500 microamps. And this is something I want to draw your attention to, that LTSpice for some reason has particular orientations that a component should be in for it to read current and voltages correctly. So if the orientation isn't proper or properly done, if the component isn't properly oriented as is expected, then it will show you negative current, not necessarily because current is indeed negative, but just because of the component orientation. Okay, so just note that once and for all. All right, so we have finished the simulation and I want us to do something a bit more complicated and not so complicated also. It's the voltage divider. If you want to change your circuit, you can just close the scope or the plot here and you can maximize your circuit once more. The first thing we are going to learn is how to delete, right? So you can click on this button here, or you can also press the backspace or the del key on your keyboard, and that's already going to activate this tool. Once it's selected, it looks like the scissors, and so we can click portions of our circuit to remove stuff, right? So I can remove this, I could remove this, I could remove this, I could even remove everything. If I select, then it removes everything that falls within the region of selection. Okay, all right, so now let's simulate a voltage divider and learn some new stuff, right? So first of all, I'm going to place my voltage source here. You press escape so that you leave that tool. Then I bring in my first resistor here, and I'm going to place the next resistor down here. So you can see that because I'm placing multiple, the reference designators have changed from R1 to R2, and if I place the next one, it's going to be R3, but I don't want to place it, so I click escape. I press escape on the keyboard and that releases the tool. The next thing I want to do is to just connect the wires. So I press W on my keyboard. I get to the point where I want to bend. I want to bend again, and now I'm going to go straight through all of them like this. Come here and come all the way here. I've made this circuit unnecessarily huge, but we are learning, right? So I'm going to place my ground here, so that becomes the reference point for measuring the voltages and the current during the simulation. The next thing I want to do is to take my output from here. So I'm going to draw a wire from here, and if I get to the place where I want to stop, you can just double click and press the escape. Okay, so I have extended a wire from there. I'm just doing this because that is where I want to probe to see the voltage that will be dropped across the R2 resistor. To make it nicer, you can actually add a net label, and net label basically is a named wire. Okay, for those of you who are familiar with tools such as KiCad or any PCB design tool, I'm sure you know of what a net label is. So here I'm just going to call it V out, and there are different types of labels. It's an output, not because it matters in this particular case, but it's an output. That's where I'm going to probe to see the output or the voltage that drops across the R2 resistor. Okay, so I click it, and then you see the orientation because it's an output. If I click anywhere on the wire, it's going to put it there. Let me just escape, Control Z to undo. I thought clicking anywhere would do, but it looks like it wants it at the tip. So I choose an output here and I'll click here. All right, so this looks nicer than previously, even though it still would have worked. So again, let's set our voltage. It's a DC, so this is 5 volt, and let's change this to let's say 5k, and let's set this also to 5k. All right, so again, we don't need a simulation to determine what's going to happen here. By the voltage divider rule, you know that voltage across R2 is going to be R2 divided by R1 plus R2, all multiplied by the 5 volt here. But again, we are starting small, right? So you have to configure your analysis, and here the stop time, like I showed you the other time, is an indication of how long the simulation should run. And then there is a time to start saving data. It's not always important to set this, but basically you can start the simulation and decide a certain point in future when Spice or LTSpice should begin saving the data. And also the maximum time steps. This determines the resolution, like so it's going to keep track of voltages and current every X resolution or maximum time step that you set here. Again, in this particular case, it's not important, but just in case you see other tools using them, then that you already have the understanding. All right, so I'm gonna put my analysis information here, and then now I can click here to simulate. So the simulation is done. Down here you can see the time axis. It indicates that we simulated for just 1 second, and up here is going to be the scale for whatever value that you are plotting. So if I click here, I'm probing what is coming outside of R2, and R2 is 5k, the same as R1, so they basically are splitting the voltage into two, and that is why it is not surprising that you have 2.5 here. If I probe what's here, it's going to show me 5 volts. So 5 volts comes in, and then because of the arrangement of the resistors here, I'm going to get 2.5 volt out here. Remember that if you want to show only one plot, you just have to double click. Okay, so if I double click here, I'm going to show just the 2.5, and if I want to see the current through any of the components, I just have to click, and you see that now I got the orientations of the resistors right. So the voltage is no longer, the current is no longer negative. It's showing 500 microamps, and because they are in series and no load is connected across the voltage divider, if I probe here, I also expect to see 500 microamps. So this is it for the next video. In the next video, I'm going to show you how to use a directive called params, and that will form the foundation on which we can begin to do even more interesting things with LTSpice. So thank you very much for watching, and I will see you in the next.